Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 2. In today's lesson, we will discuss remaining 2 questions from this paper. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 17 says, some students investigated the photoelectric effect. They used a piece of magnesium ribbon placed inside a cylinder of copper gauze as shown in the figure. There was an air gap between the copper gauze and the magnesium ribbon. The copper gauze was connected to the positive terminal of a power supply and the magnesium ribbon and sensitive ammeter were connected to the negative terminal of the power supply as shown in the figure. The students made the following observations. When light from an ultraviolet lamp was incident on the gauze and ribbon, a current was detected by the ammeter. When the polarity of the power supply was reversed, the current decreased to 0. Part A says explain these observations, and this question has 6 marks. First of all, we need to understand, for this question it is given to us there was electric current when copper gauze was connected with positive terminal and magnesium ribbon was connected with negative terminal of the power supply. So it simply means that when we shine UV light on this magnesium ribbon, in this case electrons are emitted. So simply we can say photoelectrons are emitted, or we can say photons of UV light cause emission of photoelectrons. UV light cause emission of photoelectrons. Photoelectrons simply means that electrons emitted due to light, so we call them photoelectrons. Now we need to explain what is the condition for emission of photoelectrons. So the energy of each photon has to be greater than work function of the metal. We can say work function of metal. So in this case means magnesium ribbon greater than work function of magnesium ribbon. Then we can talk about the polarity. We can say electrons are attracted to the positive terminal, means copper gauze, because this is connected with positive terminal, so we can say attracted to the positive charged gauze, we can say, because it has positive charge. And current flow, we can say current flow in the circuit. So this is we can answer. And we also need to explain when the polarity is reversed, we can say when polarity is reversed, there is repulsive force, mean this side is negative now, so this side is negative now and this side is positive. So when electron move this side, they will be repelled due to this one. Polarity is reversed, electrons are repelled and cannot reach copper gauze. We can say, or we can simply say electrons don't have enough kinetic energy to reach negatively charged copper gauze. Don't have enough kinetic energy to reach copper gauze, negatively charged copper gauze. So we can say copper gauze, or we can say cannot move across this gap. So these are the points we can write down in our final answer. First of all, photons of UV light cause emission of photoelectrons. Then we can say what is the condition for emission of photoelectrons. Energy of each photon has to be greater than work function of metal. And then we can talk about the polarity. When this side is positive, means copper gauze is positively charged. These emitted electrons, they are attracted towards copper gauze and they create current in the circuit. And when we change the polarity, there is a repulsive force that will repel electron, or we can say electrons do not have enough kinetic energy to move across the gap between magnesium ribbon and copper gauze. So these 6 points you can write down. Let me show you the answer, how you can write down your answer. This is how you can write down your answer. You can mention these 6 points in your answer. If you write down photons of ultraviolet cause photoelectrons to be emitted from the surface of the magnesium ribbon, you will get 1 mark for that. If you say photon energy is greater than work function of magnesium, you will get another mark. The emitted photoelectrons are attracted to the positively charged gauze, you will get another mark and create the current. When the polarity is reverse, current is 0 because electrons no longer have enough kinetic energy to move across the gap. It's a typical question. In a lot of papers you will see this one, so you should be able to explain these observations. A very typical question about photoelectric effect. Part B says the students reconnected the circuit so that a current was detected when ultraviolet light was incident on the gauze and the ribbon. The students replaced their original lamp with an ultraviolet lamp with a much greater intensity. Explain the effect this had on their experiment. So first thing we need to understand, we are using the same lamp. It means that we're using the same UV light, but intensity is greater, means the light is brighter. Intensity you can also understand simply more photons. If the intensity is greater, same light, if intensity is greater, it means greater number of photons, so the light will be brighter, light will be intense, it means it has more number of photons. So simply you can understand with this. This is one way to understand, but we can also understand this one with equation as well. So what is intensity? First of all, you need to understand intensity is power over surface area, and power is equal to energy over time times area, and this is the energy, this is representing total energy. But we can break down this energy into number of photons, and we can say energy of single photon, and we can divide by T times A, and this is intensity. So in this case we increase intensity but we keep the same EM radiation, means energy of each photon does not change. So what exactly it means? It means number of photons, they increase. So this is the first thing you need to understand. We can also understand this equation a little bit more. Energy of each photon, we can write down this is equal to HF divided by T times A. Now in this case, if in the question it is given to you that intensity remains same but we increase the frequency of EM radiation, mean we change the light, so how about the number of photons? They will go down, and vice versa is also true. Very important equation, relationship. A lot of tricky questions you can only answer with this one. In this case, first thing, number of photons has been increased. If the number of photons increased, now let me explain you with this simple example. If we, let's say we have first of all two number of photons, so the number of electrons, maximum number of electrons emitted from the surface can be only 2 photoelectron. This is the maximum possible number of photons, but in practice number of emitted photoelectrons are much less than the coming photons, and that's the reason efficiency of solar cell is very low. And in the second case, when the intensity has increased but we use the same light, now we can imagine, let's say 3 photons are coming, or you can say 4 photons are coming. So if 3 photons are coming, the maximum number of photoelectrons emitted from the surface can be 3 but not more than that. So this means higher intensity. We can say this is more intense light, or it is brighter. You can also say this light is brighter and this one is less bright, or we can say dimmer. So less bright, or proper way to say is dimmer. So this is dimmer. I hope this makes sense to you. So it simply means that if we increase number of photons, number of emitted electrons will increase. If number of emitted electrons increase, it means rate of flow of charge will be greater. So it simply means that current will be higher. So these are the points you have to mention in your answer. Now let me show you the answer. So in your answer you can talk about these points. The first one, you can say greater intensity increases the rate of photons emission from the lamp. You will get 1 mark. This leads to an increased emission rate of photoelectrons. You will get the 2nd mark. And the 3rd mark if you have written greater rate of flow of charge. Second part says the ultraviolet lamp was replaced by a laser which emitted red light of wavelength 633 nanometers. Deduce whether the photoelectric effect will occur. Work function of magnesium is given to us. So for this question, simply we need to calculate first of all energy of single photon. So we can say energy of red photon, that will be equal to hc over lambda. H is a Planck's constant and its value is 6.63 times 10 to minus 34 joules second, and c is 3.0 times 10 to 8, and the value of lambda is given to us. This is 633 nanometers. Now if we simplify this one, we will get 3.14 times 10 to minus 19 joules. So this is energy of red photon. And work function we have, so we can also write down work function of magnesium. This is equal to 3.7 electron volts, and 1 electron volt is equal to 1.6 times 10 to minus 19 joules. So we can convert this one also into joules. Simply we need to multiply with 1.6 times 10 to minus 19. This is joules per electron volt actually. So this is joules per electron volt. You can also see from here, for example 1, I can simply say this will be equal to 1.6 times 10 to minus 19 joules per electron volt. So electron volt will be cancelled in this case. So if we solve this one, we will get 5.92 times 10 to minus 19 joules. Now simply we need to compare these two. These two we need to compare now. So as in this case, work function is greater than the energy of red photon. So it simply means that no photoelectric effect, means no photoelectron will be emitted. So simply we can say no photoelectric effect in this case, because the work function is greater than energy of red photon, or we can say energy of red photon, as this is lower than work function. So no emission of electrons. And emission of electrons will only occur if energy of photon is greater than or equal to work function of the metal. Question 18 says a ray of light from a laser pointer is directed into a semicircular glass block as shown in the figure. There is a layer of water along the vertical flat side of the glass block. Explain why the ray of light does not change direction when entering the glass block. Your answer should refer to wave fronts. Mean in our answer, in our explanation, we have to talk about wave fronts. So first of all, let's try to understand in a very simple way. If you look at this point, the angle between the surface and the light, this angle is 90 degrees. So we can also draw here. So imagine that this is the boundary between two mediums. So this is boundary. You can imagine this one is glass. So this is glass and this one is air. To understand in a simple language, so imagine that this light is coming. So this light is coming, and angle between the surface and the light is 90 degrees. So this light simply, this will just go in a straight line, mean it will go this way. So that's the reason, as angle is 90 degree between surface and the light, so it just go in a straight line. We can also say as the angle between normal, if we draw the normal line here at this point, angle between normal, so let me use different color so you can see this one. So if I draw this normal line here, so angle between normal and incident ray is 0 degrees. It means direction will not change. So this is the main idea. But now we need to explain this one using wave fronts. Now if you look at this animation, you can see these horizontal lines. These horizontal lines, they are representing wave fronts. So they are representing wave front. These horizontal lines, they are representing wave fronts. And if you look at these wave fronts, you can see these wave fronts are parallel to the boundary between glass and air. So they enter the glass at the same time. Mean all points on the wavefront, they enter the glass at the same time. And when they enter the glass is a different medium and it has higher refractive index, so they will slow down, but they will slow down by the same amount. As they slow down by the same amount, so direction will not change. Direction only changes if they slow down by different amount. Mean they are in one medium, means some points on the wavefront they are in glass, some points on the wavefront they are in the air. So the speed will be different because air and glass, they have different refractive indices. So that's the reason. Now let me explain you in a very simple way. First point you need to say, as wave fronts, they are parallel to the boundary between glass and air and they enter the glass at the same time and they slow down all the points on the wavefront by same amount, so there is no change in direction. That's all what you need to say. Now let me show you the answer. So this is how you can write down your answer. You can say a wavefront is a line on which all points are in phase. The wavefronts are parallel to the boundary between air and glass. You can say light is traveling along the normal. All the points on the wavefront enter the glass at the same time. The wave slows down as it enters the glass block, but the whole wavefront travels the same distance in the same time. So ray does not change direction because they slow down by the same amount. So these are the points you need to understand. Now one thing more, let me explain to you. If you look at the gap between wavefronts in air and in glass, you see in glass the gap between them decreases, and the gap between two wavefronts, the distance between two wavefronts is representing the wavelength. If the wavelength gets shorter, frequency is the same, it means speed decreases. So this is telling you the speed decreases when they enter the glass. A beautiful question, why they do not change direction? Because all points on the wavefront, they enter at the same time and they slow down by the same time. So it's like running. You're holding a rod, people are holding a rod and they run at the same speed. So always they are parallel, so direction will not change. If some persons who are holding this rod, they are faster, some are slower, so they will be change in directions. Part B says, show that the critical angle between glass and water is about 60 degrees. Refractive index of glass is given and refractive index of water is also given to us. Critical angle. So first of all, we need to understand critical angle simply means that if we draw a normal line here, so this is the normal. Critical angle means that angle of refraction. This angle has to be 90 degrees. Angle of refraction means this angle with normal, this one has to be 90 degrees. So this one is over angle of refraction. So this is angle of refraction, and this angle of incidence we call is critical angle. So simply we can use Snell's law in this case. we can say n1 sine of theta 1. This has to be equal to n2 sine of theta 2. N1, we are talking about glass. So this is our glass. We are saying this is medium 1 and this is second medium. Means water, this is the second medium, not the air. So water is second medium. So for medium 1, we have refractive index 1.51, sine of theta 1. We don't know what is value of angle. We need to find out. We can say this is the critical angle. N2 is 1.33 and we have sine, angle has to be 90. So we have sine of 90 degrees. Now from here we need to find out sine of theta C. This has to be equal to 1.33 divided by 1.51. We need to find out value of angle, so we can take sine inverse 1.33 divided by 1.51. If we simplify this one, we will get 61.7 degrees. So this is the critical angle. So value of this angle is 61.7 degrees. Part C says complete the diagram to show the path of the ray of light after meeting the boundary between the glass and water. So first of all, we need to draw the normal line here. So this is the normal line. Now if you look at this angle is greater than 61.7 degrees. As this angle is greater than 61.7 degrees, it means that there will be total internal reflection. Total internal reflection. So simply you need to draw the line like this. Total internal reflection. That's all what you need to do. So in this case, these two angles, they have to be the same. If I say this angle is theta 1, this has to be also equal to theta 1. So we can say this is theta 2. So theta 1 has to be equal to theta 2 because this is total internal reflection. Means simply this is reflection but no refraction. So this is total internal reflection. So simply you have to draw the normal, then you need to draw this arrow. Part D says the photograph shows a hand holding a glass beaker containing water. Fingerprints are a series of ridges and valleys on the surface of the fingers. The valleys trap air when the finger presses against the glass as shown in the diagram below. Light in the water is incident upon the boundary between the glass and the air. The critical angle between glass and air is 40 degrees. Skin has a similar value of refractive index to glass. Very important point. Explain why the fingerprints are seen as light and dark regions. So first thing we need to understand is that skin has a similar value of refractive index to glass. So it simply means that if the light is coming from the glass, simply we can draw this arrow here. So this light will just be transmitted, it will just go straight. So light will be transmitted because glass and skin, they have same refractive index, means the same medium. So most of the light will be transmitted. So it simply means that where is the skin, that area will appear dark because no light will be reflected back. And where is the air actually? Air, so light will be reflected. So here will be reflection. So we can draw arrow here. In this case, light will come here and some of the light will be reflected. There will be reflection. So these areas, they will appear bright. So we will say these areas, they will appear brighter. So we will see light and dark regions. We will see the dark regions where is transmission of light, means the refractive index of glass and skin is the same, so most of the light will be transmitted. and where is a change in medium, at that boundary there will be reflection of light and that area will appear brighter, and that is happening where is air. So these are the points you need to understand. This question has 4 marks. So we will say where is transmission of light, those areas are dark, and where is reflection of light, those areas are brighter, because there is a change in medium. So if you got this point, now let me show you the answer. So in the answer you can mention these points. You can say some of the light traveling from the glass is transmitted into the skin. I mean, it is transmitted because they have the same refractive index. So dark areas appear where fingers is in contact with glass. Some of the light traveling from the glass is reflected from air or from the belly. Light areas where air is in contact with glass. A beautiful question, and also the last question from this paper. We have done all the questions from this paper and I have explained you all the questions in detail. I hope this video was helpful. If this video was helpful, please like and subscribe, because your encouragement is very important. And also I will really appreciate your efforts and cooperation if you can share this channel with your friends and classmates. And also if you want to support this work and you need more help, you can join Patreon.